Have you ever just stopped and thought about the invisible rules that run our entire digital lives? I mean, every time you bank online, fire up your car, or send a supposedly secure message, you're putting a ton of trust into technology. But where does that trust actually come from? Well, today we're going to pull back the curtain and look at the official rulebook for digital security.
So here's the game plan. We're going to break down the system that keeps our digital world from falling apart. We'll start with the big picture, the unseen rules of security. Then we'll zoom in on exactly what ISO/IEC 24759 is. After that, we'll take a peek inside what I like to call the digital fortress, get to know the two main players, the vendor and the tester, and finally, we'll tie it all together and see why any of this actually matters in your day-to-day life.
All right, let's kick things off with the most fundamental question of all. In this world we've built out of code and electricity, how do we really know that the security we're promised is, actually secure? Our digital lives are just this constant, high-speed blur of information, right? It feels chaotic. But underneath all that noise, there has to be a foundation of order. There has to be a system of trust holding it all together. Because without that, forget it. There's no security, no privacy, and really no confidence in the digital world we depend on for pretty much everything. I mean, really think about it for a sec. We're told our phones have super powerful encryption, our laptops, our cars, but how do we, or even the companies that make this stuff, truly know it's working right? How do we prove it wasn't implemented with a tiny, critical flaw that could bring the whole thing crashing down? The answer isn't just a company saying, hey, trust us. No way. It's a formal, global process. It's about creating a common rulebook, a shared set of brutally tough tests, so that anyone, anywhere in the world, can verify a security claim in the exact same way. And that, right there, brings us to the star of the show today, a very specific and incredibly important international standard called ISO/IEC 24759. Now, here's what's so cool about this standard. It's not some secret new kind of encryption. Nope. The best way to think about it is like the ultimate, most detailed checklist you've ever seen. It's a rule book for testers, telling them step by step how to prove that a piece of security tech does exactly what it says on the tin. No more and definitely no less. So the thing being tested has a name, a cryptographic module. Sounds complicated, but it's just the official term for that secure box that does all the heavy lifting. It could be a tiny chip in your credit card, a chunk of software on a server, or even the firmware. That's the deep-level software running in your car's brain. And believe me, this standard gets specific. It lays out all the different kinds of modules. You've got your pure hardware ones, your pure software, your firmware, but it also covers the tricky ones, the hybrid modules, where software or firmware is designed to run on a very specific piece of hardware. And the rules for testing change depending on what you're looking at. Okay, so if you're going to test a secure box, the very first thing you have to do is agree on what's in the box and what's out of the box. This is where we start building the walls of our digital fortress. The standard has this absolutely critical concept called the cryptographic boundary. This is the line in the sand. It's the physical and logical wall of our fortress. Everything inside that wall is considered part of the secure system, and it's all subject to testing. Everything outside is not. You absolutely have to define this boundary before you can do anything else. And the standard is ridiculously thorough about what testers have to identify inside that wall. We're talking every single piece, the specific processors, the memory chips, the circuit boards they're sitting on, heck, even the bits and pieces that supply the power. If it's inside that boundary, it has to be on the list. And this quote from the standard itself just says it all. Look at the language. It doesn't say the tester should consider or it would be nice if. It says the tester shall identify all hardware elements. That word shall is a command. There is a zero wiggle room, and that's why this process creates trust. So this whole system is really a carefully choreographed dance between two main partners, the vendor, which is the company that actually builds the thing, and the independent testing lab that tries to break it. The standard is built on this constant back and forth, this system of checks and balances. You can see it right in the document's codes, VE for vendor evidence and TE for tester evidence. For every single claim the vendor makes, there's a specific action the tester has to perform to verify it. So the vendor has to document its finite state model, which is basically a map of every single possible state the module can be in, and the tester's job is to prove that map is 100% accurate. It's a perfect point-for-point validation.
Now, this is so important. This testing isn't just something that happens at the very end. The standard requires something called life cycle assurance, and that's a huge deal. It means security has to be proven and documented from the absolute beginning, from the first sketch on a napkin all the way through the entire life of the product.
What that really means is security isn't just a feature they bolt on at the last minute. It is woven into the very DNA of the product, from the earliest design meetings all the way to the device that ends up in your hands. Okay, we've gone deep into the technical weeds here, so let's pull way back out and answer the big question. Why should you care about some dense, boring document with a bunch of numbers in its name? How does this actually affect you? Well, it's because this standard is what makes trust possible in our crazy complex global supply chain. When a car company needs a secure chip for its braking system, it can't just cross its fingers and hope for the best. It needs to buy a component that's been officially validated against a global standard like this one. It's like the universal seal of approval that everyone agrees on. And that seal of approval, that trust, is the bedrock of your own digital life. The reason your banking app is safe, the reason you can trust the software in your car, the systems that protect your data online. They all depend, way down deep, on components that have been through this exact kind of brutal standardized testing. And make no mistake, this is not just a friendly suggestion. This stuff has real teeth. As the foreword in the British version of the standard points out, following these rules isn't just for a certificate. Failing to meet them can have massive legal consequences. That's how seriously the world takes this. So the next time you tap your card or unlock your phone or do anything secure, just remember what's happening behind the scenes. This safety you just take for granted, it isn't magic. It's the end result of a massive, meticulous, and mostly invisible global effort to build a system of trust we can all count on. And that leaves us with one last big thought to chew on. This standard is designed for the technology we have now, but as AI, quantum computing, and a trillion connected devices become a reality, what new rulebooks are we going to have to write to maintain trust in a future that's going to be unbelievably more complex?